Welcome back, everybody. For those who haven't seen me yet, I'm Maaren Hart. I'm from the Netherlands, and I'm going to talk about flood models. In 2010, a report came out called the Flood Science Review, which is a 1,600 pages thick report about all major flood models that were available in that time. There were a lot of people involved in this investigation. Some of them were modelers, others were panelists reviewing these models. And there's Joseph Barlow who initiated this review. And he eventually wants to make a movie about Genesis flood. And there are also flood modelers not involved in a review because those are not Americans and they didn't know about models from these people as well. These are the other people that are involved in flood modeling. One of them, I don't have an image of him, is Mike Fisher. My way of doing this analysis of the flood models is I'm going to look at all statements that these flood models make, and I'm going to say whether it's true or false or plausible or anything in between. And I'm going to try to combine the best out of these models next. I'm going to see if they're compatible, because some of the flood models are just a cause of the other, another effect of another flood model. Also what I notice a lot about those scientists who make these models is that there's a lot of competition involved. And I think it's good to get rid of that and to get some cooperation there. Okay, for every model I'm going to give a short summary. I'm going to look at the main model of this, what they say. What does the model do? How does it explain the flood? Some interesting details for each model. I'm going to give some conclusions, some of my conclusions about it. I'm also going to look at what is the evidence for these models. For example, a rock is a piece of evidence. Scripture is also a piece of evidence. The Bible is a piece of evidence. And measurements are also pieces of evidence. Also, logic and physics. If A happened, then B did also happen, or if A happened, B did not. Things like that. And there's also some of the models involve simulations, which I am going to look at. Apart from the evidence, there's also interpretation, that also the other speaker in the other room spoke about. Interpretation is when you have a piece of evidence and you can look what's the cause of this piece of evidence. So you have some sand. How did it get there? And the interpretation is, well, it was transported by water. Otherwise, someone else would say it was transported by air. It's possible, but it is not evidence on its own. Interpretation of scripture also. For example, we have this one text in the Bible that says someday Peleg was born, and his name is Peleg because in his days the earth was divided. Well, what does this mean? Some people say, well, it refers to the Bible crisis that was during that time. Others say, well, this is the time when the continent split up. It's also interpretation. What I also use is what I call an uncertainty bandwidth. I say, if there's a calculation or something and it shows anything below 4 is wrong, anything above 8 is wrong, but in between it can all be okay. And 50 is not, but if it's 6, if it's 5, it's all okay. So I'm not going to choose a value in that case. I'm going to say this is the bandwidth in which it can be okay. But also for the Bible, when you have an interpretation, I only check if the interpretation is possible, if somebody says it. I'm not going to say this is the most likely interpretation, so I'm going from there. And all we are trying to do is to explain try to explain this nice blue ball we see here. It used to be underwater, according to the Bible. Yeah, what happened? All these models try to explain what happened. There's also on the Earth. There's evidence we can find, such as the Grand Canyon, or footprints. Sometimes even dinosaurs and human combined footprints, which are interesting. Radio halos, which are very much smaller. I spoke about it in another presentation. For all this evidence, you can also always make scientific models to explain these things. There are 3 scales. You have the macroscopic scale, which is a scale that is so large that you cannot see it with the naked eye. You need to zoom out, and then you can see it. There's also the mesoscopic level, that is the evidence we can see with the naked eye, such as geologic layers, but also footprints. There's also microscopic evidence that's so small that we can only see it when we look through a microscope. When we make a scientific model, every piece of evidence must fit in. If it explains 2 out of 3 things, but the third thing does not fit in, it means the model is incorrect. It's never the evidence that's incorrect. Okay, this is just an image to show what I mean when I talk about the mid-oceanic ridge, which will be back repeatedly. The mid-oceanic ridge, when I say that, I'm talking about this line in between, which is another underwater mountain range which stretches out all over the world. But just keep that in mind. So, flood models. There are quite a lot of them. So brace yourself. Okay, if a flood model, if you compare that to a meal, I'm going to give you just a bite. So we're not going into detail about everything. First one, bathtub model. What is the bathtub model? Well, actually, it's not really a model. Who models it? Nobody does. It's the layman who models the bathtub model. How do you model the bathtub model? Well, it's just reading the Bible, simplistic. And you say, well, I believe in the Bible, so water came from somewhere, rain happened, it flooded over the Mount Everest, even the highest mountain, Mount Everest, and then the water went somewhere, and I don't care what happened. So basically you would see this first, then have rain, then have water, and then have this mountains going to appear back. That's the bathtub model. It's also the most criticized model by the opposition. But that's basically a straw man model. A straw man is an argument that looks very big, but it's just nothing. And it's not believed by any creation scientist. Regular scientists and laymen just usually don't know that other models exist. And this model, all I can say about this, well, it's false. Because it does not explain anything. Where does the water come from? Where does it go? And where's the evidence? There's no evidence for the bathtub model. The flood went over Mount Everest. And the error basically is that people who do this often try to search the flood on top of evolutionary layers. So you think evolution happened for millions of years, and after these millions of years of evolution, there was a worldwide flood, and then we have the world we have today. If that would be the case, then the topmost layer would be flood layer. And when you dig it, you investigate it, you see that it's not. There's one thing that all scientists agree upon: evolution and global flood don't go together, based on these layers what we see. So you have to choose. A very popular model is the hydroplate theory. It's invented by Walt Brown, who's an engineer. And basically he is inventing a mechanism that could explain the flood. And it's based on one Bible text. The Bible text saying Noah was 600 years old when the water under the earth started gushing out everywhere. That's what he uses. He says, well, that means that water used to be trapped underneath the Earth's crust, and that you caused a gigantic water eruption, and even so much that it caused a material to should be shot into space, causing impacts on the moon and causing the asteroid belt between Jupiter and Mars, and all other stuff in the solar system. And he also says that the continents moved on top of that water that was trapped underneath it. Then he says the oceanic crust buckles up, that caused the mid-oceanic ridges. We'll get back to that later. So this is visualized what he says. Water underneath the crust, then extreme rainfall, and this sliding continents on top of this layer. And he says, well, I can explain this mid-oceanic ridge this way. If you have a spring and you put pressure on it with your thumbs and put 2 bricks in it, then if you move those bricks, then because of the pressure it will buckle out. And he says that is how I explain the mid-oceanic ridge. Okay, that's his main part. Now let's get some details. What he says is that the Earth would spin faster if subduction would happen. Subduction is something sinking inside the Earth. He says, compare that to a ballerina who is making pirouettes. If she puts her arms like that, she will spin slower, and as soon as she will put her mass towards the center of rotation, by putting her arms up, she will spin faster. You don't need more energy, just more mass near the core. This would also apply to the Earth if more mass would go to the core. There's another interesting detail which I used in my previous presentation that comes from Walt Brown. He says that we are used to magma rising upward. So we have a volcano, it's magma coming upward, becoming lava coming out. That's because molten rock is less dense than solid rock. But the interesting thing is if you compress magma, magma is more compressible than the same rock type. So you can even compress it to beyond the density of the solid rock. There is a point inside the Earth where there's so much pressure that magma will sink instead of rise. And that's called the crossover depth, and it's about 200 to 400 kilometers deep, depending on the type of rock. Another detail, when we look at the Grand Canyon, just like the Grand Canyon, there's this quartzite block we find. We find it over there. Walt Brown sometimes sees details that other people don't see. This quartzite block is of the same material of the layer below it. Now, we could say millions of years and things breaking off and going down, but we can't have this block that weighs like a bus that goes upward. So these layers that are on top of it are probably responsible for transporting this block from there to there. And the only way to do that is by making very powerful flow. So this is interesting evidence he has for the global flood. Now let's take a look at what I would consider this model. The trapped water underneath the crust is unlikely because there's no evidence for it. Continent drifting on that water is even more unlikely because for that the continents need to be flat at the bottom. They are not. They are very bumpy. You cannot move them then on water. Crust shooting into space. It's technically plausible if there is enough water inside the Earth. But causing impacts on the moon, that's not possible, because for that you need to really aim what you shoot in space towards the moon. The moon is a very tiny spot on our sky. If it just randomly moves everywhere, then the impact chance on the moon is very small, and so it cannot explain the craters there. The asteroid belt is also not like, basically impossible. The buckle, he says, for the mid-oceanic crust, for that, well, the material of oceanic crust is not capable of making that movement. It's not the right material. Earth spinning faster, that is true if subduction have happened. That's an interesting thing. The crossover depth is also true. It's confirmed by laboratory experiments. And then we have this quartzite block, it's also true. It's there and it wants an explanation. I think what he bases it on is this text in Genesis. It's plausible, but it's not the only explanation possible for this text. Next one is the catastrophic plate tectonics theory. It's by John Baumgartner. But he says, well, I try to keep most of the regular scientific interpretation intact, but I will speed it up in a cataclysm instead of millions of years. So that means the continents did not move slowly, but they moved about 1 meter per second. And then that's caused by power law creep. I'll get back to that. And there's evidence for it. The continents fit the magnetic stripes and similar geologic layers. I'm going back to these items. What he says is that first, that's also what other scientists say, there used to be a supercontinent called Rodinia, looking like this, and then moving like this towards another supercontinent called Pangea. This is the first movement of the continents, according to John Baumgartner. Then there was a second episode of movement moving like this. Now, I would say that there's quite strong evidence for the Pangea to now, but the other Rodinia, the evidence is quite weak. Subduction. What is subduction, what I said? Well, if you take a cross-section of the Earth, and you have something very heavy that sinks inside the Earth, then basically the surface of the Earth would be pulled like a tablecloth. That's how the continents then move in that case. He simulated that, and it's actually possible to get from this to this in 40 days. It is possible under the right circumstances. For that you need power law creep, which is a physical law that happens on rock. What you need for that is a lot of pressure, an awful lot of pressure, and then pull very hard, shear stress in that direction. And then when you do so, if you put twice as much pressure on it, it will not move twice as fast, it will move more than twice as fast. It's strongly non-linear. And if you put enough pressure on the rock, it will become just like water. Magnetic reversals, that's also a favorite for somebody who says the continents moved. They say there's the polarity of the magnetic field, north-south is it now, but it's also recorded in rock and sometimes it flips around so that it's down. And they say it forms stripes so that shows that the continents moved. Getting back to that. Also, something that another presenter said, that was Johan Smith. He said there is the same types of layers, geologic layers, on both sides of the Atlantic. If you would look like here South Africa and South America, then you would see that there are the same geologic layers. Also, the continents are still moving, is what John Baumgartner says. It's now only a few centimeters per year instead of a meter per second. Continents moving meter per second, well, I think it's plausible under the right circumstances. Power law creep is tested in the laboratory, it's true. Continents fitting like a jigsaw puzzle, well, especially South Africa and South America fit like a puzzle. The rest is a bit more uncertain. The stripes on the ocean floor, yeah, they are there, but the pattern is wrong, and I'll get back to that. The similar geologic layers on both sides, this is partially true. They are there, but they are far inland. So it's not perfect evidence for catastrophic plate tectonics. Continents still moving is also partially true. They are moving, but in the wrong direction. Then there's the impact model from Michael Oort. What Michael Oort basically does is he says, well, we have evidence and we start building from there. It's quite a robust method. And he says, well, we count many impacts on the moon and on other planets in the solar system. The Earth could not have been missed. Impact chance on the Earth is 90 times the impact chance on the moon. So if we calculate how many craters we should have 36,000 craters on Earth, based on the moon, with a diameter more than 30 kilometers. Then there's also 100 craters even larger than 1,000 kilometers in diameter, and I've talked about that in my previous presentation. And he also says continental basins could be craters, but he also admits that this would cause a problem, that this scenario would also destroy the Ark. Yeah. Okay, let's take a look at the evidence. This is the height map of Mars, and this is also the moon. I'll start counting craters. He's quite right that there are quite a lot of craters there. This is an excavated height map. You can see it clearly. And also we have a lot of craters that are already confirmed on Earth. Not 36,000, but almost 200. Yeah, they happen someday. Also the Vredevoort crater, which is very near here. Okay, what we see here is a height map of the Earth, but when we remove the sediments, it looks like this. And then all of a sudden these holes appear. These are called continental basins. And Michael Oort says, well, I think these are craters as well. And this is the sediments that you see fill up the craters and also the edge of the continent. There's almost no sediment on the ocean floor. My conclusion about this, well, the first statement I think is true. This is also statistically true. And the continental basins could be craters. Well, it's the best explanation I've seen so far, but I still say plausible because I can't be sure. Ark would be destroyed, well, yes, theoretically, but that also depends on where the impacts happened. And that's also, I covered that in my previous presentation. Next model is the vertical tectonics model, also by Michael Oort. There's two models. What he says is that basically the continental plates moved up and down. And when you do that, then water will splash on it and off it. He also said the oceanic crust used to be higher and the continental crust used to be lower. So when you swap that, it will flood. He also says the mountains rose during the flood. So there were many mountains before the flood. And he looks at surface features, faults, water gaps and erosion, and briefly exposed to living sediments. And he also believes that the continents did not move, contrary to what John Bauer believes. Faults, what are faults? That are these things where pieces of crust did move up and down, but not equally as much. What you see here is that this layer used to be straight, it's now there. So this moved downward. And it can be up to 15 kilometers, what we find here. It's massive. Water gaps, also Johan Smit covered that. We have these mountains that have been cut in half by water. There's evidence that it was by water, but why did the water flow here to cut these mountains if it could also have gone around it? It's very interesting that he noticed this, because water cannot flow uphill, so these water gaps need another explanation than just by a river that shouldn't be there. So what he says, well, this makes sense in the global flood. When you have a global flood, you have this flow that can move over a local mountain there, and when it does, it can carve out a hole in between, and when it sinks, it will flow around it and through that hole, and leaving this water gap. So that's a better explanation than what other scientists have about it. Grand Canyon, he says, well, we have this Grand Canyon, what everybody looks at for explaining geology, but we also have the Grand Staircase, which is even more interesting, because we don't have just this erosion of this small Grand Canyon here. There's also a lot more erosion going on over here. It's a lot more massive than the Grand Canyon itself. And when you look at other places, you see also this massive amount of erosion. Michael Hart focuses on this erosion a lot, even up to 5 kilometers. What he says is, well, basically when there is a local mountain and water flowing over it, a sheet flow, then it will erode very fast if this water is very fast. Then it takes away the rock there, causing it to be less heavy, so moving up even more, causing these erosion patterns. Another one is beds, briefly exposed diluvian sediments. What's that? Well, there's one problem that creationists have, or used to have, that there are dinosaur footprints on top of some of these layers, and sometimes you have a layer with footprints, then a sediment layer, and again a layer with footprints, and even dinosaur nests. And they say, how can this happen in a global flood scenario where every piece of the world is just wet? You can't have dinosaurs walking underwater. But he says, well, if these things didn't just move down, but also up and down all the time, then it would flood, but also be exposed briefly in between. So during the first, say, 40 days, it went up and down, causing some of these dinosaurs to drown, but also some to survive to get in the next layer. We also see evidence of these dinosaurs. They are almost all just buried in sediments with their neck bent backwards. It had been suffocating during this, that it was buried, causing its neck to be bent backward. So you can see on the evidence that the dinosaurs drowned, contrary to what they believed, that it was a meteorite that killed them. Well, I'm going to skip this a little half. I'm going because of time. There's one issue that I want to focus on. He says there are no magnetic reversals, because he says there's no continental movement. He also says there's no movement. There's no magnetic reversals. Okay, for all his own things, I think it's very likely. His model is very strong, his way of doing things is very robust. And some things are also true because you can see them, and these faults, they are really 15 kilometers. It's a plausible concept. Erosion, also likely. And when it comes to the no plate tectonics, I think there is where Michael Hart is going into some errors, especially about the magnetic reversals, because there's evidence that the magnetic field did reverse. And the next model, I'm not going too much into detail about this one. It's Philip Budd. He says, I want a defensible flood model as an alternative to secular geology. The main parts, he says, well, water was not trapped underneath the crust, it was trapped inside vugs, like a sponge, inside the crust. He says that the Precambrian layer were high power flood layers. Well, I'll explain later what Precambrian layers are. He says during the flood everything got pulverized and everything on top of the Precambrian layers is after the flood. Then he says continental subsidence means just the tilting of the continents is very important for his model. And the collapse of this sponge-like crust that released a lot of water, causing the Genesis flood. That's his model. He says there's evidence mud volcanoes, there are actually mud volcanoes do exist in Armenia or something. When we have this image back of the Grand Staircase, Grand Canyon, this is the Precambrian layer. That's what Philip Budd says are the flood layers. And he says the rest are all post-flood, after the flood, because he couldn't fit it in his own model. But actually the Precambrian layers are only 20% of the sediments. So subsidence, well, we can see an example of that here. Conclusion for me, I think his method is not wrong. I don't want a defensible model, I just want to know what happened, and as long as I don't want to know what happens, I will keep on searching. Fuggy crust, well, theoretically plausible. Precambrian layers, high power flood layers, I think that is also plausible, but then that would be the start of the flood. Everything getting pulverized could also theoretically happen, but I think the most unlikely part of his model is that everything else is post-flood. It's just too large. Continental subsidence, well, we see evidence for that, and this collapsing of the interior, well, we have some mud volcanoes, but it's very rare. And the position of the sediments is not correct for it. There's also this amateur that made another model. He has a video that shows it. Oh, no, first. What he does is looking at some macroscopic features and trying to explain it in one event. And he says there used to be one supercontinent, like Pangea, and it breaks into continents and it moved from one single point. And the impacts were pushing, the impact was a pushing force. Okay, here's the movie. This is basically what it means. Impact there, causing to break up and push in a way. That's the idea. Well, one thing that is right about, rock does not break slowly. You cannot break a rock slowly. You need to smash it and then it will break into pieces. And the continents are 50-kilometer thick granite, so you cannot break that slowly. Also, very near to where he points is half a crater. It's a Shiva crater. And the magnetic stripes, he is actually looking at it in more detail. John Baumgartner says it's evidence for continental movement. Mike Ward says it doesn't exist. Well, the fact is, they do exist, but they have a very weird shape. And if this would be continental spreading, recording this magnetic reversals, we would need to have perfect stripes. These are not perfect, so they are there, but they are not evidence for John Baumgartner's model. The one large impact, well, it's partially false. I think there was more than one impact, but I think the impact could have broken the crust of the Earth. Continents moving from that point, I think, is plausible. Impact is a pushing force. I think that's wrong. Imagine it like this: if you put a rock into clay and you want to move it, then you need to push it for a very long time, pushing pressure on it. If you take a gun and you will shoot it, it will just break into pieces, but it will not move. You cannot move it through clay, but the same applies for the continents. There's something in the way blocking it. Shiva craters, I think that's likely. Magnetic stripes exist, that's true, but they do not they do not work for spreading ridges theory. Next one is a smaller model. It's about salt only. Someone I know, Stef Hirma, I know personally. Well, he found an error in the standard explanation for these salt layers, and he has an alternative explanation in which the flood works better. We have this salt layers that have salt pillars on top, which are kilometers high, 4 kilometers high, vertically. They are buried underneath the earth, but they are very impressive. But he says salt has been in a molten state, water flew on top of it, crust forms, and then strange ruptures. I'm going to show this. That's easier. Well, where are these salt pillars first? This is the Netherlands, where I live. We have these salt pillars over here. If you take a cross-section of it, then you will see that it is sticking out vertically for almost 4 kilometers, in some places in the world even more. How did they get that shape? Well, what he says is that this salt used to be molten, then water went flowing on top of it, forming crust in this on this salt, but because it's solidifying, it shrinks, and when it shrinks, it ruptures. So when it ruptures, there's still a molten salt below it, causing it to contact the water again. And there will be steam columns forming there, causing bubbles. And those bubbles are lighter than the thing around it, the water around it. So the salt will go upward because it has nothing blocking it there. It's pulled upward by the bubbles. I think he's right that the standard theory does not work, basically because the standard theory is that the layers on top of it are heavier than the salt, causing millions of years the salt to go through these layers. But he examined the salt, and the salt is actually heavier than the layers on top of it, so the standard theory doesn't work. The salt that appears to exist have been in a molten state. I think everything he says is actually likely. And the last one I'm a little bit less certain about, but I say it's plausible. It's just maybe I'm a bit biased, but I don't know. Then we have the recolonization model, which says, well, what I said, Philip Budd says, here's the flood. Michael Ort says, this is all flood. Almost all, until I think here. But some people say the flood began here and the flood ended here. Everything on top is is post-flood. Okay, the modelers are looking for the flood, but takes them geology very seriously where possible. They have more than 40 arguments. I'm just going to take 3 out of them to show what they mean. And they say these Paleozoic layers are very strong. You can see that it's flood layers. The rest on top of it has features that show it's not flood layers. And he says the Earth used to have disasters even 300 years after the flood. And they say the continents moved from Rodinia to Pangea during the flood, and afterward, when Peleg was there, the continents got divided. That's what they say. Why do they say there's post-flood? Well, we have these red layers over here, and these red layers there, that's basically rusted. And when it rusted, they say it must have been through air. They also say this rock was shaped by air. That's what they say. They also say there are dinosaur nests there. How can dinosaurs make a nest during the flood? So it must have ended there. I think what they say about the Paleozoic layers is likely, but I think that the rest is post-flood. Well, all the things they say are plausible. It's not a bad model, but I think all these things can also be explained within a flood model. Especially the red beds, what they say is post-flood. We also have red beds in the Paleozoic layers. So if they say that is post-flood, then the other layers is also no flood. So it's not consistent. I think the split up from Rodinia to Pangea is very unlikely. And Pangea to now, well, if you have one continental movement event, and that was so devastating that you needed an ark to survive, why did it happen again? Did you not need an ark? It doesn't make sense to me. Okay, this is the next is a very small model, based on 2 Bible texts. God said, "I command a dome to separate the water above it from the water below it during creation." And then it says later, during the flood, the sky opened like windows and rain poured down for 40 days and 40 nights. They say, well, they have two different ideas about it. There used to be a canopy of water vapor around the earth. That's one idea. Or there used to be a solid canopy, it's a spherical construction around the earth with water on top of it. And that collapsed when the windows of heaven opened, causing the rain. The vapor canopy is actually, that has been calculated, it's not possible to contain that much water. A solid canopy In theory, you can make a construction that fits around the Earth, but it's very hard, and there's no evidence that there has ever been one. So these models are basically abandoned by creationists by now. There's also the no-flood model, basically the evolutionary model. Well, all non-creationists are working on it. And basically they say the present is the key to the past. Billions of years, Wilson cycles, that's the continent splitting up, going back together, splitting up, going back together, all over the time, throughout history. Spreading ridges, they say the continent, the oceanic, mid-oceanic ridges are ridges from where the continent spread. And that's what they say. Multiple mass extinction, evolution, and well, I'm not going into detail because you have heard too much about this already. Present is the key to the past. Well, I think that we can prove that it's false. We see things in the Earth that do not form today. So there are no longer processes going on to form those layers. So the idea is false. Billions of years, different subject, not going into discussion about that. Wilson's cycles, well, if you have these continents to move from one point to another, you have something heavy sinking inside the Earth. If you would move the continents, then the heavy part would be down and there would be light material on top of it. Why would it go down again in reverse? To me it doesn't make sense. Spreading ridges, that says that the magma is rising from below these mid-oceanic ridges and there it spreads. There is magma below the mid-oceanic ridges, but it's very shallow. You see, it's not very deep. There is no source for this process. Also, Africa has these spreading ridges all around it. They say continents move away from the spreading ridges. But when Africa is completely surrounded by these ridges, which way does it move? It cannot move all the directions at the same time. So it doesn't make sense. Multiple mass extinction, well, on itself it's plausible if you ignore the Bible. Evolution, I have made YouTube movies about this. You can watch them 2 hours in total. I'm not going to discuss it now. There are also people who say, well, there was a flood, but it was local. Now, there are various models available. And they say a local flood is the inspiration of the worldwide flood in the Bible. I'm going to take one example, just to see what happens. The Black Sea theory. What they say is their entire known world was flooded instead of the entire world. And they had to evacuate, so they took the pets with them. And the evidence for this particular model is that there is an ancient shoreline and there is a flooded civilization down there. And they say, well, the Bible, it's about the moral, it's not about the details, it's no history. People are bad and God punishes. Yeah, that's the idea. Okay, well, the local flood, this is actually what we see. We see an ancient shoreline, and we see that the Black Sea is actually larger today. So it got flooded in the past someday. But the evidence is not an entire civilization, it's one tiny village. So, yeah, that's very different. If you compare that to the Bible story, well, just pick some of these sentences, read some random sentences. It does not match the local theories at all. I mean, if God commanded Noah to build an ark, and he was over here, where it was not safe, and he was working for 120 years to build an ark, get in there, and then go ahead with the flood. Why did God not command him to walk over there? It doesn't make sense, no. Yeah. The Black Sea got flooded, well, it's true, but it was a post-flood event. There's the ancient shoreline and flooded civilization. No, it was one flooded village, not a civilization. The known world got flooded, well, Noah could have walked away easily in days. Inspired, they had to evacuate, so it took pets. Well, it doesn't remotely look like the Bible story. Read it again if you don't believe me. It's about moral only. No, it's false. The Bible has mostly technical details. The moral is only a very tiny part of it. It's also not just a nice story to read. It took so many days, so many meters, so many, no. It's not a nice bedtime story whatsoever. Then there's my own model. That's the last one. Just stay awake for a couple of minutes. Okay, what I try to do, I try to use all these models that are available, investigate them, and then investigate the remaining mysteries. So I'm not going to start over from scratch. What I showed in my previous presentations is that all the models have one thing in common: it's too much heat. But most of the heat is actually still inside the Earth, so it's not too much heat, it just ended up inside the Earth. There are three types of heat transport: flow, radiation, and conduction. If you want to see my other presentation, you can see it on YouTube. Impacts, cratering, converting into heat sinks and hotspots, heat sinks causing continental movement. Well, I'm going to show what that means. And the mid-oceanic ridges, I think it's a closing scene. Okay. So what happens if we have a top view and we have a crust that is just starting to break up? Then eventually we would have this, these things moving apart, like John Baumgartner says. Then you have, for example, Africa here and South America here. And then there would be a lava flow in between. And this lava flow causes this water to move away from there. One way is to evaporate it, and it rains in the cold part, but also because it expands and it pushes away the water from that location and it pushes it on top of the continent. So this is the reason why the Earth got flooded. And when it does, this lava has all the freedom to expose all of its heat towards the universe, causing it to solidify. I calculated that it fits the biblical time, but you have to see my other presentation for that. Then, when it does, the water will try to get back on top of this lava, causing a conflict here. Very much heat and much of rain, a lot of rain, cooling it down, pressing this crust more inward towards the middle of the oceans. And eventually it would close up because two layers would be lying on top of each other, causing a mid-oceanic ridge. That's the main idea. And this is the situation we have today: mid-oceanic ridge, continents, sediments over there, and almost no sediments on top of the oceanic crust. My conclusion, well, I think that's true that they have a heat problem, but I can fix it. The heat is still inside the Earth, and that's very likely. There are three types of heat transport, there's no discussion about that. The rest of the model I would just consider it plausible. Why? Well, I think this is a theory that works, but I cannot say for sure it works. It's an interpretation. I cannot say it happens this way. Okay, now if we take a look at all these models, and we have to choose which one of these models is correct, we can look at it in three ways. Most people say, well, I take the most advanced model, because, well, I have here a scheme schematically showing the errors and the good things. In reality, some of these models are much larger than the other. If you take the largest one, that has the most details, then you would go for the no-flood model. Basically because all scientists are looking for no flood and evolution. If you think, well, I'm going to take the models with the least errors in it, then I think you would go for Michael Ort's model, because that's the most robust model. But why throwing away all the good parts of the other models because you like one above the other? If you like the Michael Ort's model, why throw other models in the bin, even though they have truths? Just, if we do it this way, then you can cut off all the errors of all the models and combine the best of the other models, the best of the models that you have combining all the truths and building an all-over model. So what could have happened? Well, if you would have an Earth day and night to show a bit of spectacular things, you would have the day zero, there was no rain yet, no flood. Then there could have been meteorite bombardment on one side of the Earth. The other side we couldn't bombard that much. Then that would break the crust and cause a lot of heat flow around of it. And also it would cause the continents to move. And if you want to know why, you have to see my other presentation. Then after day 40, it would mean that the Earth would show like this. This is night and this is day, but even in the night it was shining brightly because of all the lava that was almost everywhere, covering 70% of the Earth. And then the rest of the part would, the rest of the Earth would rain. After 200 days, part of it got solidified, so that the water was moving back to the, or actually not back, but it was moving on top of this lava, causing it to close up. After 300 days, you would have the people could get out of the ark, and it looks almost like this. And then eventually we are left with the Earth we have today. So thanks for your interest. I hope you got flooded by information.